What if I told you the definition of subtraction we all learned in elementary school was wrong? That's because subtraction does not mean taking away something. Okay, if that's true, then what is the definition of subtraction? When we subtract whole numbers, we write it like this. 7 minus positive 3 equals some number. But we can also write this as addition like this. So, now we have positive 3 plus an unknown number equals positive 7, where the unknown number is one of the addends. And, of course, the unknown addend is 4. This is the correct definition of subtraction. Finding the unknown addend when subtraction is written as addition. In each case, we're subtracting positive 3 from positive 7. You may not be familiar with this definition of subtraction because it was adopted by mathematicians only recently in the last half of the 1800s. Some of the mathematicians who advocated for this change are shown here. The reason this change occurred so late in the history of math was that without this change, mathematicians could not fully accept negative numbers as legitimate. The change was first adopted in algebra, and it's taken many decades for this definition to work its way down to elementary and middle schools. And that's the source of the problem if you learned the old, incorrect definition of subtraction in early elementary school. Because in middle school, when we try to explain subtraction of integers, that makes it even harder to understand the rules that must be learned. But it is important to note that this definition of subtraction, finding the unknown addend, or finding the difference, is now the one called for in almost all state math standards, starting in grade 1. Recently, in 2019, a distinguished panel of math and math education experts also pointed out that this change in definition of subtraction is, quote, one of the essential understandings students will need in middle grades in order to extend arithmetic to negative rational numbers, unquote. And remember that rational numbers also include integers. This change in the definition of subtraction was actually very simple. Before, subtraction was thought of as taking away something. If we were to show subtraction on a number line using the standard format, it would almost always be shown as counting back from 7 to 3. We would start by counting the number 7, which we will show like this. Then we would take away 3, which is shown by counting back on the number line 3 times, which we show like this. But, as we just said, this is not the correct definition of subtraction, and it's not shown like this on a number line as counting back. Instead, since the definition of subtraction was changed over 150 years ago, it's now defined as finding the difference between two numbers. This is referred to as the unknown addend definition. You may also recognize this as another more familiar way of describing subtraction. It's called the counting on approach to subtraction. Here's how we show this on a number line using the correct definition, finding an unknown addend. We count positive 7 by starting at 0 and counting to the right as we did before. The only difference is we now also start at 0 and count to the right for positive 3. We don't take away anything or count back. Instead, we count on from 3 to 7 to find the difference, which is the unknown addend. We show that like this. That means the only difference between this and the counting back approach is that we start counting both numbers, 7 and 3, at 0. As a reminder that this is what subtraction means, we put this minus symbol below 0. The reason we start at 0 for each number is very intuitive and easy to understand. The difference when we subtract 3 from 7 is the difference between these two numbers on the number line, 3 and 7. So, starting at 0 just means we're placing each number on the number line, then counting the distance between them. But now, because we're dealing with integers instead of whole numbers, we also need to know the direction in which we count the distance. As a reminder to find the direction, we always start at the number we subtract, which is positive 3 in this case, and we count until we reach the number we're subtracting from, which is positive 7. To find the distance between these points, we ask the question, what number do we add to positive 3 to get to positive 7? We count 4 times to the right. That tells us two things. The first is that the answer is a positive number because we counted to the right. The second is that we counted 4 times to reach positive 7, so the answer is positive 4. The good news is that this process is exactly the same when we subtract any integers in any combination, either positive or negative. We place the two numbers on the number line by counting both numbers starting at 0. Then we count the distance between them. Here's another example to illustrate this. Instead of subtracting positive 3, we're now subtracting negative 3. We start by writing this as addition with an unknown addend. And we put these on the number line using the same approach. It doesn't matter which number we put on the number line first. To be consistent, we'll start each example by putting the number we're subtracting from, which in this case is positive 7. So we start at 0 and count to positive 7. Then we start at 0 and count to negative 3. So now we ask the question, where do we start counting? As always, we start counting at the number we subtract. Next, we ask the question, what number do we add to negative 3 to get to positive 7? So, starting at negative 3, we count 10 times to the right. So the answer is positive 10, which is shown by the red arrow. Here's another example, negative 7 minus positive 3. We start by writing this as addition with an unknown addend. Here, positive 3 is subtracted from negative 7. Again, we start by putting both numbers, negative 7 and positive 3, on the number line, which we can do in either order. We'll start by counting to the left to negative 7. Then we count to the right for positive 3. Then we ask the question, what number do we add to positive 3, the number we're subtracting, to get to negative 7, the number we're subtracting it from? We start at the number we're subtracting and we count to the left 10 times. So the answer is negative 10. One last example. First, we rewrite this as addition with an unknown addend. Next, we start by putting negative 7 and negative 3 on the number line, starting at 0 for each number. Then we ask the question, what number do we add to negative 3, the number we're subtracting, to get to negative 7, the number we're subtracting it from? We count to the left 4 times. So the answer is negative 4. We've now illustrated all the different combinations of subtracting positive and negative integers. They're written in both standard subtraction format and as addition with an unknown addend. When we write each equation with an unknown addend and show it on a number line as we've done here, there is one major benefit. It makes it much easier to show why the rules for subtracting integers make sense. We'll look at that in a later video. If you found this video helpful, hit the like button and subscribe. Click on the bell to get notified of our latest videos. We value your time, so thank you for watching.